Hello and welcome. I am on page 25 of your quarter 2 algebra 1 notebook. In this video, we're going to talk about writing linear equations when given the slope of an equation and the y-intercept. So from a previous unit on graphing linear equations and inequalities, we learned that slope-intercept form is y equals mx plus b, where m equals the slope of an equation, or the change in y over the change in x, your vertical change over your horizontal change, and b equals the y-intercept, which is the value of y when x equals 0, or where a line crosses the y-axis. So if we're given enough information, knowing that my x and y's in the linear equations, there are infinite points that work for any given an equation. If I know m and I know b, I can write the equation. So y equals mx plus b. The directions here: write a linear equation in slope-intercept form when given the slope and y-intercept. Well, I need to substitute for m and b. M equals -2. So y equals -2x, and b equals a positive 3 plus 3. So there is the equation with a slope of -2 and a y-intercept of 3. On our next one, we are given the slope of 1. So if I think about y equals mx plus b, if I'm to substitute in a 1 for my m, as a mathematician, I'm not going to write 1x. I will just write x with that invisible 1 there. My y-intercept is 0, 4. So it's the value of y when x equals 0, so plus 4. Sometimes we're given a verbal description of what is happening, and we need to make sense of what is going on. We're still looking to see y equals mx plus b. An airplane is 3,000 feet above the ground, and it begins descending at 2,000 feet per minute. Remember that slope equals a rate of change. So you can see that 2,000 feet per minute is a rate of change, so that equals m. In this case, 3,000 feet above the ground is the value of y, your vertical, when x equals 0. So my equation for this particular situation is y equals descending is negative, because I'm moving down left to right, negative 2,000 x plus 30,000. And there is the equation for that particular situation. All right, now we're going to move on to, we had given slope and y-intercept, verbal description. What if we have some graphs? So in this particular graph, first thing I always like to look for is that y-intercept. Where does that line cross the y-axis? It crosses at -1. And the slope, of course, is the change in y over the change in x. So I'm going to count down 1, 2, 3, down 3, which is -3, to the right 1, +1, which equals -3. Substituting into the equation y equals mx plus b, I know that y equals -3x minus 1. So look at our next equation. Looks like I'm going to have a positive slope. So, well, I like to find the y-intercept first. Here's my line crossing the y-axis at 2. My slope is the change in y over the change in x. I'm going to go up 1, 2, 3. So that's a +3. And I'm going to go to the right 1, 2, 3, 4. That's a +4. So my slope equals 3 over 4. Substituting into y equals mx plus b, I get y equals 3/4 x plus 2. So far, so good. Why don't you pause the video and try to do number 6? So hopefully you came up with a similar equation. I found my y-intercept here at 1. I found the second point at 1, 2, negative 1, 2, 3. So my second point was at 2, negative 3. And calculating my slope, I went down 4, which is a negative 4, to the right 2, a positive 2, and my slope ended up being negative 2. I could have also found this point right here, and I would have gone down 2 to the right 1. Again, negative 2. So y equals negative 2 plus 1. Let's move on to page 26 and continue this journey. We have written equations when we're given the information, written equations when we're given a graph. Now it's time to write an equation in slope-intercept form when I have a table of values. So again, the first thing I'm going to look for is b. And remember that b is the y-intercept, and that is the value of y when x equals 0. So you need to look for where x equals 0. Here it is. X equals 0 right there when y equals negative 2. So there's what my y-intercept. Now with my slope, I simply need to choose 2 points, changing y over changing x. So I'm going to use that slope formula. And I have 1, 2, 3, 4, 5, 6, 7 points to choose from. It just depends what you want. So I'm going to choose 6, 1, and 4, 0. So if I'm calculating my slope, m equals, I'm going to have this be x2, y2, x1, y1. So I have m equals 1 minus 0 over 6 minus 4, which equals 1 over 2. So my slope is 1/2. And my equation, lots of writing here, is y equals 1/2 x minus 2. Always writing things in slope-intercept form on these particular equations. Why don't you pause the video and give number 8 a try? So maybe you started this problem thinking, I'm looking for my y-intercept first, which is the value of y when x equals 0. So you're looking for your zeros in x and you didn't see it. This is when you have to kind of think about what is happening. If I start at 7, I know that I am subtracting by 1 each time. And lo and behold, 1 minus 1 is 0. So because this is a line or a constant rate of change, my change in y should be consistent, and indeed it is. Minus 2, minus 2, minus 2, minus 2, minus 2, minus 2. So 5 minus 2 is 3, and that is where my y-intercept is, at 3. Now, by looking at this particular table in this way, I'm already calculating my change in y, which is negative 2, over my change in x, which is negative 1, which is a slope of 2, and my equation is y equals 2x plus 3. So moving on, sometimes you need to find, using 2 points, one of which is the y-intercept, find the slope. Then write a linear equation in slope-intercept form. So in this lesson, we are being given the y-intercept, the value of y when x equals 0. So b equals 5. Now I need to use my slope equation. Sorry, I don't know why I wrote that. I'm thinking about y equals mx plus b, but m equals y2 minus y1 over x2 minus x1. I'm going to label my points. So I got x2, y2, x1, y1, and that's going to equal 5 minus negative 7 over 0 minus 2. Of course, I know 5 minus minus is really 5 plus 7, which is 12, over 0 minus 2, which is negative 2, and that equals a negative 6. So my slope is negative 6, and my equation, y equals negative 6x plus 5. Why don't you pause the video and see if you can do number 10 on your own? All right. So this is, of course, written in functional notation, but we know that functional notation is f of x. Here's my x equals 0. So my y-intercept is -7, the value of y when x equals 0. I just rewrite these as ordered pairs. Label my ordered pairs x1, y1, x2, y2. -1 minus -7 is -1 plus 7, which is 6. 3 minus 0 is 3. 6 divided by 3 is 2. So my slope is 2, and my equation is y equals 2x minus 7. The final part of this video is going to be looking at how to write the equation of horizontal and vertical lines. And at this point, you need to start thinking about what you know about horizontal and vertical lines. When we were graphing equations and inequalities, we learned that the slope m equals 0 for our horizontal lines. And we then learned that m equals undefined for our vertical lines. So we can use this information to know what type of line we're thinking about. So if I have a slope of 0, I know this must be a horizontal line. So with horizontal lines, I always have the same y value. And my same y value is going to be the y-intercept. So in this case, y equals -2. And if you think about graphing that line, if y equals -2, here's my quick, y equals -2, here's the y-intercept, and y would equal -2 repeatedly, and I would get a horizontal line with a slope of 0. So looking at this line, my x values are the same, which will result in a denominator of 0, which means you have a vertical line where your slope is undefined. And for your vertical lines, you're thinking about the value of x, and x equals 3. Because x is 3 at every point in that line, no matter what value of y. So let's take a look at number 13. When I see this graph, it doesn't matter. I know my slope is 0. This graph really is all about y equaling 1, 2, 3, 4. Y equals 4. Likewise, with a horizontal line, y values differ, but what stays the same are your x values. Your x values are consistent, so x equals -1, -2, -3. And that is the equation for horizontal and vertical lines. That's all for this video. Thanks so much.